In a previous video, I talked about how I would like to get to the point where I could build code, build applications with C or C++ that I can run on my 286 system. Well, to do that, I have a lot of work ahead of me. And as I look at it, I've got to build the hardware, and I have a 286 system that runs well at this point. And that has a video card and a sound card, and both of those seem to be working fine. On top of that, I'm building, really to make that hardware work, a basic BIOS, and that BIOS runs on my system and lets me do things like write to my video card or play sound, take keyboard input, mouse input, etc. Then on top of that, I have some operating system type of functionality, and so far, really, that functionality is built right into my flash ROM along with the BIOS. I haven't separated it real well up to this point. And I'll show you some things in this video that I'm doing to try to maybe help me with that. And then I get to this application level, and I want to be able to go into C, C++, build something, compile it, and then have the operating system load it and support it so that that application can do things like call DOS functions, which would be this interrupt 21. And within that interrupt, there's all of these functions. And an example I have on the screen is this 40. So if when you raise interrupt 21, if in the high byte of the A register you have a number 40 in hex, that indicates to the operating system, to DOS, that you'd like to write to a file or a device. Well, inside of that, it might turn around and need to write to, let's say, a video card, actually write some characters to the VGA memory. And to do that, it's going to reach down into the BIOS and take a look at raising interrupt 10 and using the 0A function within it to write a character at a cursor position. So all of this kind of stacks up, and the idea of the BIOS really is to abstract the hardware from the operating system, and the idea of the operating system is to abstract everything underneath it to the application. So that if I can get enough pieces built, I should be able to work in this higher level C, C++ type of world and not have to do everything in assembly moving forward. And that would be great. I have some things started on this, though, that are letting me maybe see how this is going to flow and how things are connecting. And I do have my first extremely simple Hello World working that is written in C. So I have a C app that I'm going to load through the operating system. I'm going to say that with air quotes around it. So this operating system that I'm running inside of my flash memory, but it's going to load up this DOS COM file. It's going to run it, and when it runs, that COM file is going to raise interrupt 21 to the operating system, and I'm going to respond to that, and then I'm going to turn around and do things like write to a file or device, which might then raise interrupt 10 of the BIOS so that I can do video service, and in this case specifically this 0A function, so that I can write a character out at wherever the cursor is. And then of course that's going to have to write to the actual RAM on the video card to make that work. So I'm going to walk through maybe what I'm working on, and again I'll put out this asterisk that this is all very new to me, so you're probably going to see more stuff that's wrong than is right, but I guess I'm trying to just show the general approach I'm taking more than anything. And I know I have a lot of incomplete code here. I'm cheating a bit in some of the code, and I'll point that out when I get there, but I'm trying to just learn how this all comes together. So maybe I'll start out, I'm going to pull up this program here. This is TerraTerm, and here's my computer. I'm going to go ahead and do a reset of it real quick. And the first thing it does is it initializes the video RAM, and then, gets into doing all my post tests and brings up the real-time clock and temp and things like that. And this little nano I have sitting here lets me write debug information out to the PC, to this serial window that I have open. And you can see that when it starts up, it does a bunch of SD card testing and reads back some data from that. No big deal. But what I want to now be able to do is run a DOS program. And maybe I will real quickly just show you the DOS program. So I'm going to come over here to my Visual Studio and pull up Hello C. And so you can see this is a very simple one-liner. I'm including the stdio, the standard IO, and then I'm doing a printf of hello world. And that is the code that I build into a COM file, and I want to run that COM file. Now on my 286 screen, you'll notice that I have my just standard where it comes up to with my prompt, and I can type in help. And one of the things I can now do is say run DOS COM, and that's going to run that command that I just built, basically that hello.com that I built from that C code. And when I run it, you'll notice that to the output, it now says hello world. And in the debug screen, I'm logging all the interrupts I've received from that compiled C program, the COM file, into interrupt 21 of my operating system. And I received, looks like an interrupt 21 function 30, which is asking for the DOS version. And then it asks for setting a block of basically allocating memory or deallocating memory, I believe is what the set block is for. And then it asks for the version again, which I'm not sure why, but it did. And that, again, that could be something messed up in the way I'm approaching this, but that's what, as far as I can tell, it's asking for. And then it asked for a get lead byte table, and then did a set block, and then it does an IO control, and then a write, and then it terminates. So those were all of the interrupts that my pseudo operating system received. And when it received the write within that, it was passed in 0C for the length of what it needs to write. And then I go fetch it and I write it. Now to do that, I then raise the interrupt 10 of the underlying BIOS to actually write those characters, hello world, out to my screen. And you'll see on the VGA output that I'm recording, that's what it did. It says hello world. So that's what I'm going to walk through, is how did I set up that framework, right or wrong, and just show you kind of what I have going on there. So I'm going to start out with my Visual Studio in my 286 code, and I'm going to, again, go back to this hello world, and maybe I'll just modify that. So let's say hello world, and I'm going to put in 319, just so it's a different string. I'm going to go ahead and save that, and then I want to build that. So down on the screen at the bottom, I have a batch file and that I'm going to run. And it just basically uses this open Watcom, and it just built that file up above, compile it into a .com file. And I can go open that .com file real quick. And so here is this .com file, and I can't zoom into it, at least within Visual Studio here, because it's a hex file. It probably doesn't know how to do that, or isn't set up to do it very well. But I can see that in this, there's some embedded stuff that Watcom wrote in there. And if I go all the way down to the bottom, here I can see my string that I want to write out, hello world 319. So that's been built. I'm going to go ahead and close that file. What I now do with that file is I go into my main assembly, and at the end of my assembly, I have a section where it's the boot vector, first of all, so that when the computer turns on, this is what tells it to go to the very top of my code and start running. Right above that, I have some ROM data, and that's, a lot of strings and font character data and some sprites and things like that. But before that, I told it to include the binary of that hello.com file. So it's going to just take the raw binary that is in hello.com, which is, compiled C, and include it raw in my flash ROM. So essentially what I've got going on here, my flash ROM has my BIOS for my 286, plus I'm embedding within it a COM file. Now, the reason I'm doing that is I don't have IDE support. I don't have a FAT file system running yet. So that all makes that a little challenging to put it onto, let's say, a drive and have it read it off the drive. And that's fine. I'm learning, and I'm working on that other IDE control stuff separately, so I'll come back to that at some point. So for now, I just said, let's put it into the ROM. I'll load it out of ROM and see if I can make that work. And so I now have this code I've been working on, and if you've been following my video series, there's been a lot of stuff that I put in here. I have recently split a lot of stuff out and put them into separate files, like all the video code goes into this vga.asm, all the sound code goes into sound.asm, etc. One of the things I put over here, though, is an OS file, And so anything that I've kind of deemed as DOS-like functionality or operating system functionality, I'm putting into this file so that later I can strip it out easily, put it into its own separate build that would be on a file system that my BIOS would basically hand off control and let that operating system boot up and take the system. So anything that's in here that I'm kind of saying is operating system type of stuff. And again, for now, since I don't have a drive running, this is all running from my BIOS chips, my flash chips. My flash chips now have BIOS plus operating system plus a COM program all within them. Now, in this, if I point out a few things, let me go back to my main program. When my main system starts up, there is a top section that it runs, and in that I do set up interrupts. And I'll show you right now what interrupts I have working. So I've got a divide error, which is like a divide by 0 would get me to an interrupt service routine that I can process that. Overflow, invalid, operation or opcode, multiple exceptions, keyboard, mouse interrupts, video interrupt, and that's interrupt 10 hex. And now I've also added in DOS services interrupt 21. So that's my hex 21, which would be normally your DOS services. And those DOS services really are part of the OS, so I put that into the OS file. And within that, then I'm going to go in and check, and I'm going to look for things like DOS terminate. So if it's an interrupt 21, it'll get into this procedure, and then I check, is it function 0, which is a terminate? Is it function 30? Is it a version? Is it a 3D open file, etc.? And so I put in some of these to kind of get things working. You might be wondering why I put certain ones here on my webpage on this blog post about using C, C++. I had previously built a C++ file, same thing as what I was just showing, and then I disassembled it with NDIS ASM, and I got out a list of which interrupts it was calling, which interrupts, which functions. And I kind of distilled that down and said, okay, if I built it with C++, this is what it seems to be expecting from DOS, is interrupt 21 with all of these functions. Well, that's what I did over here when I built this. I built a hello.com just now as we're going through this video, but previously I had done one. And if I look, I have, let's see if I can find it here, a disassembled version of it. So I disassembled it. And that disassembled version looks like this. And within that, then I could go and look, where is there an int that gets raised? And I could search through all of it. And here I can see there is an interrupt 21 function 4a. So then I got to figure out, well, what is 4a? Why is it calling that? And if I go back over here, I can look up and say, oh, no 4a there. So I go to a different reference, and this stanislavs.org has a nice reference that I've been using. So I'm going to go to interrupt 21, and then I'm looking for 4a. And when I get to 4a, I can see that that is a modify allocated memory block or a set block. Okay, so it wants to tell my operating system what it's looking for memory. And if I keep searching, I might find another one here. It's a 30. So it is function 30 that it's specifying in the high byte of the A register, and then calling interrupt 21. And a 30 I had in my list over here is a get DOS version number. So at some point it's checking for what version of DOS I'm running as that C++ or C program is running. And so I've implemented some of that functionality here. And so like DOS version, if you ask if that interrupt gets raised and function 30 is specified, I'm going to return a 5.0. So 5.0 is the version. So that's stuff that I'm doing inside of this DOS interrupt service routine here. And I'll come back into that in a little bit more detail shortly. So I've built a COM file. I've put that COM file into my flash ROM. And then I've also built this little mini operating system that I'm starting to work with and put that into the flash ROM. So my flash ROM, again, has all of those pieces that you saw in those initial graphics when I'm talking about BIOS operating system in an application, at least until I get my IDE drive running. What I've done other than that is I've gone in here and actually, this command that I typed, I have a list of commands that I support typing in at my console, if you want to call it that, on my 286. But one of those is if I choose to, let me find it here, run DOS command. So if I run that, if I type run DOS command, it'll get into this part of my code. And then that's going to call this command run DOS command. And if I look at run DOS command, you can see what I do here. Basically, what I'm going to do is I'm going to go out and copy from where I initially placed that DOS program in my ROM, and I'm going to bring it into RAM. And I'm going to bring it into RAM at a specific location, and that location is going to be brought in here. You can see the target buffer is ESDI. So if I go to ES, that's 2000 and DI 0. So at the address of 20000 in RAM, I'm going to load that DOS program. And so I copy that program into RAM, basically load it up, and then I jump to it. And the program actually, when I'm copying it, it seems like DOS uses this initial offset of 100. So I just did the same thing. I don't know if it really doesn't matter since I'm doing my own thing here. But basically, this is now saying go to that 2000 segment and go to the offset of 100 within that. In other words, it's going to go to 20100 for my address. It's going to jump there and start running code, which is whatever that DOS program has at the beginning. And if I went and looked at the disassembly, the first thing that does is it does a jump. So it just says, okay, jump to 01A. So it's going to jump to somewhere down here and start running. Okay, so then I have my DOS program. And let me go back to that one more time real quick. And at the end of it, I have the Hello World 319. So that's been built. I am now going to go ahead and build this 286 code. So the 286 code, then once I get it on, the idea is that I can go to my keyboard. I can say run DOS command. It's going to take that DOS hello.com, put it into RAM, and start running it. And then the goal is to see if it works. What does it do? And if it works, what I should see is that there are interrupts that it's raising, really this interrupt 21, which then over in my pseudo operating system over here, I'm then going to catch that interrupt down here in my ISR, my interrupt service routine, and then I'm going to check which function is it. If it's function 0, do this. If it's 30, do this, etc., etc. And one of those is going to be a write. Now, let me just build this. And as a reminder, I've got this little utility here that if I have it running when I do a build down here, so let me do a build of my 286 source code here. So I'm going to go ahead and run that, and then you'll see over here it's automatically transferring the updated built flash ROMs over to my Arduino Do. And that doesn't take long. You can see the last time I ran it, it took 12 seconds. This time it's taking 16 seconds for whatever reason. But now on my computer here, I'm going to reset this. What I can do on my computer is one of the commands you saw when I typed help is to do an update BIOS. So I can just say update BIOS, and it's now going to take that staged BIOS and it's rewriting my flash chips. You probably can't see this on the video, but I added a percentage progress. So it's showing me what percentage complete is it. And at the end of that, it's going to make a call to this little nano, and the nano is going to actually physically reset there. Instead of me pressing that button, it's going to pull it low for me, and it's going to reset the entire system as part of this update process. And so, this is a quick update to get that latest code onto my ROMs, so we can see if we can get the hello with the updated date that I put on there. So my computer's resetting, loading, and now I'm back up. And I'm going to go ahead and type help again. There's my choices, and I'm going to do this run DOS com, And there's my hello world 319. So you can see those changes I made took effect. And at the end of it, I just halt the processor at this point so that the system's actually shut down. So I'm not going to be able to do anything, but that's fine. That's where I want it to stop, at least for now. So let me show you what it went through when I ran that. So over here on this little debug window, as I received interrupt calls from the hello.com, I logged it, and the first one I received was an interrupt 21 function 30, so it asked for a DOS version. So that means over here that it would have run this code where I handled that interrupt and I sent back a 50, and I did logging, right? So in this I log out interrupt info to this output, and then I wrote a little V just to know I'm in that procedure over here. And then I put into the AL, and this should actually be interesting. That is a bug. So that should be AH. So this is a major and minor version. So previously I had that at 1 and it would kick out of the DOS program. So I don't know why the version I just had worked, but anyways, this should be telling it. And if I want to know if is that right, I can come back over here and I can just look up that DOS version. So that was an int 2130, and it tells it that on return the major should be in the AL and the minor should be in the AH. And so it wants that in hundredths decimal. So AH, let's just say I want to have a 0. So AH, yeah, 0, and then AL 5. So this should mean a 5.0 DOS that I'm trying to emulate. And if I had moved 0 into that AX, that meant I was telling it was 0.0, which probably wasn't real helpful. But anyways, so that was the first interrupt I got. The second one was a set block, so that's a 4A, and that's to basically inform the operating system about increasing or decreasing memory, as I understand it. And again, I can go look that up and say, well, what is an interrupt 21 and then a 4A for the function, and that is to modify allocated memory. And so this comes in with a request, new requested block size in paragraphs and segment of the block. Okay. What I'm actually doing when it comes to like that example, and again, this is a 4A, so I've got these in hex order, so I get down to a 4A. I just log out the little B that I got into there, and that's it. I get out. So I'm actually not even allocating memory. I'm just kind of ignoring it. It asked me to do something, and I said, okay, fine, and I kept on going. And that's fine. I'm just trying to stub this out and see how these are flowing. Then it asked for the DOS version again. Then it asked for a get lead byte table. Then it asked to set block again. And then it asked for some I/O control of some sort. And so 44... when I get into this, again, I can go back and look up, well, what does 44 tell me? And so int 21, and then I get a 44. And within a 44, there's actually quite a few choices. Let me back up. Here's just plain old 44. But I can see that if it's a 44 and then a 00 after it, so 4400, that's a get device info. And if I go into that, it tells me about what kind of info can I get back about this. So that program is asking about device information of my system. And again, on my code, when it comes to this I/O control, I know it's asking for 4400, but I'm not doing anything with it. I'm just not returning anything helpful for it. So that's something I'll have to figure out. Okay, what specifically should I be returning? That's okay. I'm going to keep going. Then I look at this and I see that, okay, then it eventually gets, and it wants to do a write, and it wants to write 17 characters. So this is hex, but that would be 17 in decimal. So 17 characters, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, I was just counting up this string data that I had put in, and that would be 17 characters. So it's saying, I want you to write out 17 characters, and it specifies a starting address or where that buffer is at. And this is a spot where I'm cheating a little bit because I haven't gotten all the work done yet. But in it, when I go to do a write, I get down here and there should be a file handle, and I'm actually not opening files or properly doing any of the handle stuff yet. And then CX should be how many bytes, and that's coming through with the correct number of 15. And then it's supposed to have a pointer to where the actual buffer is that contains the data. And for now, I'm not using that. I'm just saying I know it starts at this. So anytime I use that compiler for that seed that I was using, it ends up that my string data starts at this address here, which actually is 20AA, and then I need to offset it at 100 because of where I loaded it. But I know this is the address, so this is cheating. I know that. I need to actually make that dynamic and figure this part of it out yet. I just haven't gotten there. But I tell it where the data is stored, it passes in how many characters, and then for every character I raise an interrupt to my video. And I go to interrupt 10, and when I call interrupt 10, I put a 0A into the high byte, which tells it function 0A, which is write a character at the current cursor. And then what's in the low A is what I had already retrieved earlier, which would be pulling back the next character basically in this loop. So I point to a location, it's got a string, I grab a character, I print it, and then I increment that to the next location is the way I'm doing this, and then it loops, and then I grab the next character and I print it, etc. So this is just a loop that runs through raising int 10 to get it out to my actual video card memory. And then after it does that, it does a terminate process for C. And then when I look at my for C, I really terminate. I mean, I terminate hard. I just say halt. Really, at that point, I'd want to jump back to my operating system again and give you a cursor and let you continue doing things. But for now, I just wanted to stop there to kind of see if I can make this stuff work. So that all seems to be working. And if I go look at interrupt 10 for a second, that's over in my VGA, and that would be in this handler. And when interrupt 10 comes in, technically any interrupt that is interrupt 10, no matter what the function is, I'm going to do the same thing, which is to write out a character at the current cursor. So I call existing code I already had that did that. So at some point, I need to support more than the function of 0A. And right now, I'm just making a dangerous assumption that the only time this is going to get raised is when I raise it, which I think is true, because nothing else on my system is smart enough to raise interrupt 10. But this will have to get to be a much more detailed set of code. But for now, this is good enough because this is the only function within interrupt 10 that I support. And so I'm going to assume that any call to it is trying to print HR. Okay, so at this point, I've gone in and I've built an assembly file, or not an assembly file, sorry, a C code file. I have compiled that into a hello.com. I've embedded that hello.com along with my little operating system support into my flash ROM. I've programmed my flash ROMs with that. And then when the program runs and I go to the keyboard and I type in run DOSCOM, it goes out and grabs the raw binary for the hello.com, pulls it into RAM, which I have sitting up here, and then jumps to it. And as that code is running, which is all of that assembly essentially that I reverse, reverse that back out to say, well, what does that look like in that compiled COM file? In it was doing things like checking my DOS version, trying to allocate memory, trying to write out basically this character data. And as it's doing that, it's raising interrupts. My system is responding to those interrupts from the operating system perspective. It's turning around and calling lower level BIOS interrupts to actually do the printing to the screen. So that all kind of seems to be starting to flow a little bit as I go through this for me. So I know I have a ton of work to do, and each one of these interrupt calls like this IO control, there's a lot to it. And all I did on all of these is I just pretty much said, forget it. Whatever you're asking for, I don't care. Just keep on going through the code. And then I tried to get to the point where I'm actually doing a write. And when I do a write, outside of debugging stuff that I'm writing, I just kind of cheat and tell it where to start reading. And then I iterate through and print out characters. And I think that's right. And so what I need to do now is actually grab DSTX, figure out what it's pointing to, and make sure that I can get to the same data. I know DSTX is not coming in the same as 21AA right now, though, and it's probably because of a previous call. For example, when I try to actually set up this file handle, it might be pointing to a file name or something like that, and I'm not getting something sent back to it properly. So I don't know yet. I need to research that more, and I'll keep digging into that. But the result is, what you're seeing over here on the terminal screen. I can see it got these interrupts, and it asked me to write out 11 or 17 characters, and that was what the data was. And then you can see on my LCD output, it actually shows that I got that hello world 319.